everyone. In this video, we're going to learn how to find the derivative of an inverse function. Okay, and we talked about inverse functions in our first unit on functions. So if you've forgotten about inverse functions, I reposted that video along with this video. Okay, so if you feel like you're rusty on inverse functions, then go back and watch the video on inverse functions. Okay. But remember that inverse functions undo each other, and so they switch your input and your output. And if you recall, to find an inverse function, that's exactly what we would do. We would switch x and y and then solve for y. Okay. All right. So if f and g are inverse functions, then by the definition of inverse, we know that f of g of x is equal to x. And remember, that was a way that we could verify that two functions are inverses of each other. We would compose them and then simplify and make sure it's simplified to x. Okay? So this is the definition of inverse functions. All right, so we want to find the derivative. So we're going to take the derivative of both sides. So I'm just going to use my derivative operator. I'm just writing it in front of each side. Okay, now to find the derivative of the left side, we'd have to use chain rule because we have a composition, f of g of x. So remember that derivative, we would start with the outside. We would get f prime of g of x, keeping the inside the same, but then multiplying by the derivative of the inside. So that is literally the definition of chain rule. Okay? Equals the derivative of x is just 1. Okay, so since we're trying to find the derivative of the inverse function, which would be g of x, we're just going to now solve this for g prime of x, which is the derivative of g of x. So to solve this for g prime of x, since I'm multiplying on the left side, we would just divide the 1 by f prime of g of x. And that basically is the rule for finding the derivative of an inverse function. Okay? If g of x is the inverse of f of x, then g prime of x is going to equal 1 divided by f prime of g of x. Okay? All right, so here's kind of our formal definition. Let f be a function that is differentiable on an interval I. If f has an inverse function g, then g prime of x would equal 1 divided by f prime of g of x. Okay, and that basically is what we just wrote on the previous slide, but I wanted to show you where it comes from. Okay, so this is just another rule that you need to know. But let's look at some examples of how we might use this. Okay, so in this example it says if f of x equals x squared plus 3x, and g of x is the inverse of f of x, then find g prime of 4 when g of 4 equals 1. Okay, so if we use our rule, okay, if we're trying to find, remember we just said g prime of x, if g is the inverse of f, is equal to 1 divided by f prime of g of x. Okay, so if we want to find g prime of 4, we're just going to replace x with 4. Okay, so we're going to end up finding 1 divided by f prime of g of 4. Okay, and literally we're just, all I did is replaced x with 4 in our rule. Okay, all right, now this problem is not too bad because they tell us what g of 4 is equal to. Okay, g of 4 is equal to 1. So this is just going to become 1 over f prime of We've got a little work to do though, because we're not given f prime, we're given f. But that's okay. If we know what f is, we can find f prime by finding the derivative. Okay? So f prime of x would equal 2x plus 3 using the power rule. And then I want f prime of 1, so I'm just going to plug in a 1 for x. So I get 2 times 1 plus 3, which equals 5. And so then I can replace f prime of 1 with 5, and then g prime of 4 ends up equaling 1/5. And that's the final answer I'm looking for. Okay, let's look at another example that's a little more complicated. If g of x is the inverse of f of x, which equals x squared minus x for x less than or equal to 0, then find g prime of 2. Okay, so we can do this without actually finding g of x, okay? Which would be a little tricky here, because to find g of x, we'd have to take f of x, switch x and y, and solve for y, okay? And that would get a little tricky with this particular function. All right, so instead we want to use our rule, okay? Now remember, if we start with our rule, okay? So remember the rule is g prime of x is equal to 1 divided by f prime of g of x, okay? So to find g prime of 2, we're initially just plugging in 2 for x. Okay, now, we've got to figure out g of 2, okay? Well, remember that your inverse function switches your input and your output. So, to find g of 2, we could take f of x, set it equal to 2, okay, and then solve it for x. So, to find g of 2, we're going to set f of x equal to 2 and solve for x. Okay, so let's do that. F of x is x squared minus x. Put that in a different color. So we're going to set that equal to 2 and then solve it for x. So we're solving a quadratic. So we would want to subtract the 2 on each side and set it equal to 0. And then let's try factoring. So we're looking for factors of -2 that add to -1. So that would be x minus 2, x plus 1. All right, so we get x equals 2 and x equals -1. Now, we're going to go back to our original problem because I want to point something out. It says if g of x is the inverse of f of x for x is less than or equal to 0, okay? So if x has to be less than or equal to 0, we're going to eliminate the x equals 2 because 2 is not less than or equal to 0. And we're going to stick with x equals -1, okay? All right, so that is telling us that g of 2 would equal -1, okay? And if you're still wondering where that came from, by setting f of x equal to 2 and solving for x, that's telling us that f of -1 equals 2, okay? Which would work out if you plugged in a -1. -1 squared is 1 minus -1 would become 1 plus 1, which equals 2, okay? And so remember, if these are inverses, they switch your x and y. Okay, so hopefully you see where your x and y is switched. But this is really what we need to solve our problem. Okay, because our original formula is g prime of 2 equals 1 divided by f prime of g of 2. Well, we just figured out that g of 2 is equal to negative 1. Okay, so I'm going to go back up here to our formula. This is now 1 over f prime of negative 1. Just replacing the g of 2 with negative 1. Okay, so now all we have to do is find f prime and then plug in a negative 1.
Shante Smith, if you're in the building, please report to room 110 at this time. Again, Shante Smith, report to room 110 at this time.
Okay, so to find f prime, we're just going to find our derivative using the power rule, 2x minus 1. And then to find f prime of negative 1, okay, which is in our formula, we're going to plug in a negative 1 for x. And we get 2 times negative 1 minus 1. And that would end up equaling negative 3. So if I go back to my formula now, I have my final answer. This is going to equal 1 over negative 3, which is equal to negative 1/3. Okay? So g prime of 2 is equal to negative 1/3. Okay. I know that was a lot. But we are just starting with our formula. If g is the inverse of f, then g prime of x is equal to 1 divided by f prime of g of x. And since we wanted to find g prime of 2, that's just replacing x with 2. So we get 1 divided by f prime of g of 2, okay? In order to find g of 2 without having to actually find g of x, okay, which would be a lot of work, we can find it by setting f of x equal to 2 and solving for x, okay? So that's what we did here. We took f of x, set it equal to 2, solved for x. We got x equals negative 1. So then our formula became 1 divided by f prime of negative 1. And then to find f prime of negative 1, we just found the derivative of f and then plugged in a negative 1, and we got negative 3. And so going back to our formula, that gave us 1 divided by negative 3, and then we just simplified that to negative 1/3. Okay, so we're going to practice this some more in class tomorrow, and I will see you then. Have a good night.